Alright, so for the final exams for modeling, it's basically separated into three parts. It's the first part is section A. It's multiple choice questions, totaling up to 30 marks, 30 marks for section A. Then we have section B, which is the short answer questions, and that totals up to 60 marks. So they're short answer questions and pretty much structured, but they also have a lot of marks behind it, a total of 60 marks. I guess throughout this revision, what I'm gonna do is I'm gonna go chapter to chapter, and I'll just highlight the parts that you really need to focus on in the earlier part, and the rest of the stuff will kind of fall into section A, which is the multiple choice questions. And finally, for the remainder 10 marks, that will come from section C, which is a question on how to model something if you were given an image. And this is similar to the makeup assignment that you did right down here. Okay, so if you've done the makeup assignment and you understand your modeling methods and which method should be used in one particular object, you should be okay when it comes to answering section C. So again, just to repeat, there's section A, which is multiple choice questions, objective questions. That's 30 marks. Section B, structured short answer questions, at 60 marks. That's a lot, and you really need to focus on that. As well as section C, which is the essay question on how to model an object, which is similar to the makeup assignment, and that's 10 marks. Section A, B, C. Okay. Alright, so let's go on to the chapters. Alright, so hello everyone who's taking modeling. I hope you will find this video useful. Basically, what I'm going to do now is to kind of do some revision for you to sit for your final exams. I wish you all the best of luck, although you might find that the tips I'm gonna give you will be handy for you to know which parts in the lecture slides for you to read. Right, cool. So I am here now on Moodle. Okay, basically these are all the lecture slides from chapter 1 to chapter 9. Now the good news is chapter 9 will not be in the finals. The bad news is chapters 1 to 8 will be. So, but still good news is that, you know, I'm gonna tell you exactly where you should focus in each one of the chapters. So without further ado, let's go right into there. Alright, so let's start with chapter 1, computer modeling primer. Sorry, I know for a fact that right, page 5 here, this is pretty important. What is 3D modeling? What you need to kind of really pay attention to is how 3D modeling can be useful. Right, so basically this part, you just need to really understand what I'm trying to convey here in this slide. Alright, and that's about it. Let's just focus on another part of the lecture, basically this part about subdivision surfaces. So basically there's, you know, 3 types of digital models. What you need to focus on is subdivision surfaces. which is this one here. Right? Really understand what subdivision surfaces are, what it is in essence, and also why is it popular in the modeling world, why computer modelers, computer artists use it a lot, why is it popular, and that you really need to kind of focus on. What else? Alright, this is page 33. This part, basically vertex maps. What I want you to do is really understand what vertex maps are. Yeah, and we've done a lot of texture mapping in the labs, even in your projects. So really understand what texture maps are, how they're also called UV maps sometimes, and what they're used, how they are used in modeling, as well as there are other common types of vertex maps like weight maps, morph maps, color maps, selection maps. Please focus on all this. Try to understand exactly each one of them, and you should be okay. Alright, so basically that's about it for chapter 1. But of course there are other stuff that I will ask in the in section A, in the multiple choice questions. In particular, understand what these images are, what you're seeing here. Yeah, what kind of software is used to perform this kind of computer simulation. What else? Not so much on the history, but if you've done a lot of modeling, in particular the NURBS part, you understand that we use curves. Yeah, so in particular probably this slide, and when I talk about curve, just focus on that part. And if you've done a lot of modeling, you should know pretty well by now that there's lots of different curves. There's the CV point curve, there's the Bezier curve, and if it relates to the history, that's what you need to focus on. Jumping on, understand what you're looking at here. This is the Cornell box. Understand what I'm talking about when I talk about the Cornell box. What else? Let me see. Oh, we already touched on this one, and also that one. So in general, the earlier parts that I was focusing about, the one I was talking about, those go into section B, the structured questions. They're kind of short answered, but if you kind of pinpoint to exactly what I was talking about, you should be fine with this. Yeah. Alright, so let's move on to chapter 2. Alright, so here we are in chapter 2. Chapter 2 is, of course, professional modeling practices. Let's just see. In particular, what you really need to focus on in this chapter is the discussion on the difference of offline rendering and real-time rendering. Don't confuse between the two. Understand what offline is, what real-time is. Here's a good explanation. Please read through this. Identify how they're different, what kind of industries relate to these two different renderings, and you should be okay if you cover all that. Page 17 in the second chapter. Of course, there's two things when we talk about clean modeling. Is polygon count and topology. Now what you need to focus on is, why do we need good topology? I mean, why is it useful? Don't confuse between topology and polygon count. Know what is topology and why do we need topology. Yeah. The reasons for good topology and whatnot. Page 22. As well, when we talk about trying to create good topology, we employ edge loops. Yeah, and I always stress this in the lab. If you're gonna add edges, make sure they're a complete loop. But what I don't stress on is the why of it. So this is the why of it, and you gotta really focus on the reasons why it's essential that you create edge loops in order to get good polygon flow or good topology. So focus on this page as well. And finally, page 24 of the second chapter. Of course, you know by now from doing lots of the lab assignments that I always stress that you need to keep all of your polygons not in triangles, not in n-gons, but in quads. Yeah. Right. But the reasons of which, I mean, you know why, since you've been doing modeling, the reason is, if you don't keep it quads, you get smoothing errors. But basically this is two of the reasons, outlined to you very clearly, the reasons why you need to keep things in quads. So focus on this, really understand this, and if you can, give me a reason why we need to keep things in quads or 4 points, you should be pretty much okay. So really understand this part. Alright, so as for the multiple choice questions, they actually, it's basic stuff, since, the whole chapter is about professional modeling practices, and what I really want you to focus on is the clean modeling part. Understand what it is made up of. Basically the two things, polygon count and topology. I'll talk about this. If you understand what offline real-time rendering is, you should be fine with the multiple choice questions. And if you really understand what topology is, you should be okay as well. Understand what it is. Don't memorize it, but you can basically topology is how the mesh is constructed, how you lay out the polygons, how it's arranged to build up its shape. I mean, if you really understand that how the polygon flows, the other name for topology is polyflow. So if you understand that, you should be fine. Just don't confuse yourself between topology and polygon count. It's pretty straightforward. Hopefully you're able to nail this chapter really fine. Alright, so let's move on to the next chapter, which is chapter 3. Alright, so chapter 3, preparation for modeling. Well, not much from this chapter, although there are parts that you really need to focus on. And I'll go straight into page 20. Alright, so really understand where do the professionals, means that the professional 3D modelers, get their reference material. What are the common resources when they are about to start to model something? So we have all these 8 common resources when it comes to modeling. There's explanations for all this, and please go through that. The other part that you need to focus on in this chapter is basically the references that you should avoid. And when I talk about that, it's all this 4 stuff. And again, you gotta not just kind of memorize what are the references to avoid, but I want you to really understand when I talk about, for instance, inadequate reference. What does it mean by inadequate reference? Give me examples of inadequate reference. If we're talking about illustrations and digital models, why should you avoid it? The reasons of why you should not use this kind of reference in your work. And when we're talking about this, what does it mean by photos with extreme lighting conditions and whatnot. Okay, all right. So basically, only two parts that you need to focus on. Again, let me just repeat it for clarity. So, where do you get? What are the resources that the professionals go to when they're trying to get reference material, as well as the discussion on references to avoid. Okay, so that's all you need to focus on. All right, so let's move on to chapter 4. Right, so we're here in chapter 4. Again, not much from chapter 4 because it's polygonal modeling, and you've done a lot of polygonal modeling, and a lot of things that you learn in this chapter is basically hands-on, and it's all been done while you're doing the lab assignments and the project. But of course, we gotta go by theory as well to answer the final exams, and I'm gonna go straight to the page that you need to focus on. So let's go to page 8. Alright, so this, or basically the manipulator gizmo in your 3D program in Maya. They're separated by world and by local, and here's an explanation of what it means when I say by world and what it means by local. You need to really kind of be able to understand this and put it into words when we're talking about the manipulator gizmo orientations. Okay, so this is quite important. Not quite important, it's pretty much important. Let's go to page 17 of chapter 4. Right, welding. Welding is a good polygon operation to use. Some of you did use it in the labs, but if you don't know what are the safe techniques when using welding, chances are you won't be able to weld your mesh properly. So focus on welding and the discussion on how to ensure that you get a nice mesh and the safe techniques that you use when welding. Okay, right, and finally soft edges, page 23. So soft edges basically talks about how you should not kind of give me sharp edges when you're modeling, like what you see here. That's a sharp edge, and I know a lot of you do that in your projects, but hopefully they turn out okay with soft edges if you were to introduce them. Right, so with soft edges, there's a discussion here on why you need soft edges. So please read through this page 23. Kind of note on the reasons of why you need to introduce soft edges when you're doing polygonal modeling. Alright, so that's pretty much it for chapter 4. Let's move on to chapter 5. Right, so we're in chapter 5, computer modeling methods. Now I would say this is a chapter that you really need to focus on. Yep. A lot of you seem to confuse on all the modeling methods when you were answering the mid-semester exam, and with good reason. I kind of repeat it in the final exams. But the good thing is I'm gonna tell you exactly what you need to focus on. Now, so we have all these methods, all these methods that conform to computer modeling methods, but I'll just tell you exactly which method you need to focus on. What you need to really understand is first the build out method. Okay, so the build out method is there's two categories, two techniques that fall under it. First, it's the point to point, and number two, the edge extend. Okay, what you need to really understand is why would you use the build out method. I mean, what kind of meshes can you create? As explanation here, that you can use it to model low poly model for games. You can use it to generate custom letter forms like what we see here. They also use a lot in the modeling of realistic heads, to create characters in animation and games. So that's it. Why would you use the build out method? So please really tune into that and focus on that part, as well as why. Not exactly why, but there are two tasks that relate to the build out method, and one of them is retopology. What I want you to do is kind of really understand what retopology is and how it works. If you don't understand this, there is a YouTube video that accompanies chapter 5, so you can read more about it. It can pretty much illustrate what I mean when I talk about retopology, but here as well there's an explanation of what retopology is, so really understand what this is, so you don't get confused, because it's the word is retopology, so I don't want you to confuse it with the discussion in chapter 2 about clean modeling. Alright, this is actually retopology in chapter 5. Topology itself, that's a different thing, although it's related, but don't confuse yourself. Topology, focus on that. Okay. What else? Page 19. Alright. So of all the modeling methods, the one you need to focus on is the build out method, as well as this one last method that is in the list. Out of the 8, the build out method, as well as this one, the modeling with texture and animation tools method. Now you need to really understand what texture displacement is, the use of displacement maps to model a terrain perhaps. You need to understand what it is, as well as what kind of objects you're able to model with this kind of method, the use of bones, and what dynamics are and how they can be useful when you want to use it in modeling. Alright, it's separated into two parts. There's the soft deformable objects like this cloth here, as well as rigid simulations, rigid body simulations like what you see here, probably perform in a software like RealFlow, like what we see in chapter 1 earlier. Let me just go back to there. Alright, so understand what RealFlow is and how we can use it in modeling. So dynamics, focus on that, the two categories, and what kind of software you might use to model such a thing using simulations. Right, so just to recap, alright, and one last part is the digital sculpting method. Alright, if you really want to see a demo of how this is performed, again, there's that chapter 5 YouTube videos you need to open, and it'll show you exactly how the digital sculpting method works. Not so much here, you just really need to kind of read through this part of the chapter in terms of what kind of software they use to perform digital sculpting. Of course, there's the two famous ones. There's many others, I assume, but the two famous ones are ZBrush by Pixelogic, as well as the one by Autodesk, which is Mudbox, which we have in our labs. Okay, so when we talk about ZBrush and Mudbox, understand which method that it falls into. Alright, just as a recap, basically, of all these methods, what you need to focus on is the build-out method, the digital sculpting method, as well as the last one, modeling with texture and animation tools method. Okay, so that's pretty much it for chapter 5. Let's move on to chapter 6. Right, chapter 6. This is a fairly long chapter on shading and texturing. Let's just go to the page where we need to really focus on, and that is the Fresnel effect. The Fresnel effect, understand what it is. Not necessarily the origins of it, but I want you to understand the concept behind it. Okay, the observation of the amount of light you see reflected off a surface depending on your viewing angle. So if you're looking at the surface of a water, you know how much reflection you're getting depending on how you look at it. So understand what Fresnel is and where can you observe Fresnel. It's not just on a water surface. Fresnel happens in pretty much everything. It's just it's more obvious on pretty reflective surfaces that has a lot of gloss. So focus on the Fresnel effect. Not much, it's just 3 slides, but really understand it. Okay, now other stuff that you need to read through in this chapter that will go inside into the multiple choice questions in section A is this one, identifying tactile quality. Well, you don't really need to memorize all this. What I want you to do is kind of go through this part, section A, and really kind of just understand the concepts behind it, the explanation on how bumpiness works, what influences roughness in a surface, how you can get smoothness on a surface, as well as, you know, how things look different depending on the kind of inhibitors it has on it, like, you know, dirt, rust, scratches and whatnot. So just focus on part A of this chapter, which discusses about the about identifying tactile quality. Other stuff. Now this is a long one, mapping surface attributes. Yeah, so we have all these maps that you've been using in Maya when you're doing texturing: color maps, specular maps, incandescence, transparency, displacement, and whatnot. Let's just focus on the 2 things that you really need to focus, which is on page 38, transparency mapping. Okay, as well as the discussion on page 42, displacement mapping. Just understand what they are. Well, they're pretty straightforward. Transparency mapping is used to give to make some parts of the object invisible, while displacement mapping basically is for you to change the mesh, the shape, the silhouette of a surface when you apply a displacement map. And it's similar to what you get in chapter 1 here. Remember, sorry, not chapter 1, let me just yeah, it's similar to what you get inside here. See, texture displacement. So if you've read about this, you will pretty much understand what displacement maps are. Okay, so yeah, but yeah, Oop. Right, so pay attention to transparency mapping as well as displacement mapping. This too is pretty much important, and it's what you need to focus on when we talk about mapping techniques. Okay. So that's pretty much it for chapter 6. Although, remember this part in Moodle? Chapter 6, additional reading. So this is important as well. It's not just for you, for your own good. I would advise you to go through that one. When you open the additional reading, chapter 6 additional reading, what you get is this chapter from the book, Lighting and Rendering, which discusses about designing and assigning textures. What you need to focus on is page right down here, page 16. Alright, aligning maps with models. Okay, so well, basically what this is the UV unwrapping that you did in Maya using the UV editor. Remember, getting a model and kind of using projections to unwrap the 3D mesh. So here's a discussion of how you would align maps with models. First thing is probably, if you're doing a lot of NURBS modeling, you can use assigning UV coordinates. That's related to implicit UV coordinates, and that's related that relates to if you do a lot of NURBS modeling. You can also assign UV coordinates, and we don't do this because this is kind of hard thing to do. What we did was we used projections, and that's what we mostly did when we use the UV editor. We have planar, we have spherical. The other thing that we did not do is this one, using p-text, and I want you to kind of read through this part in particular, adopting p-text. What is per face texturing? Alright, that's quite important for our discussion. So please go through this. It's not a long discussion, but I just want to get your head around this whole thing. That's why I kind of went through all this, aligning maps with models. Just understand what this is, what that is, using implicit UV coordinates, what using projections is. Basically that's what you did in the labs, and what you really need to focus on is the new technique of using p-text, per face texturing. Alright, let's move on. The other part that you need to look at is about decals. Okay, so decals are basically layering your texture with more textures which has been masked out using an alpha map or a black and white image, allowing you to layer your texture with more things like dirt or graffiti or patterns and whatnot. So here's a discussion about decals. Please go through it. It's not that long, it's just that much, 2 pages, less than 2 pages. So focus on that. So basically 2 things, decals as well as the one on page 19, p-text. Okay, so please do open up the PDF called chapter 6 additional reading. Alright, with that, let's move on to chapter 7. Now chapter 7 is about lighting. What you really need to look at is this discussion on the visual functions of shadows. Shadows are useful. They kind of help to direct one's eye. They're also useful for a lot of things, which are all outlined here, as well as discussions on why and how you can use shadows for all of these different functions. Alright, so focus on this long list of the visual functions of shadows. So that's chapter 7, page 30. Let's go to page 13 in chapter 7. Alright, so types of light. Types of lights. Of course, there are many, and for the most part in the lab, you kind of just use sky domes and area lights. And also I kind of showed you how to use directional lights. Okay, so that is what you need to focus on. What are directional lights? Please don't confuse it with the other types of lights like point lights and spotlights. Understand what directional lights are. But basically it's for you to kind of mimic how the sun light is in a real environment. Okay, so understand what directional lights are. The other stuff is this. So right through the end of this chapter, there's a discussion about ambient occlusion, AO for short. Let me just go to the agenda of this chapter. So right through the end, there's shadows and occlusion, as well as subsurface scattering. What you really need to focus on is the occlusion part as well as subsurface scattering, and that is all that information is contained on page 39, which discusses about ambient occlusion, what it is, and you've seen me rendering some of this ambient occlusion paths and how it can be used in your renderings. So if you see like a picture like this constant lighting which gives you all the shadows, please do understand what it is and don't confuse yourself with other terms. Ambient occlusion, well, you can, just by looking at the word, you can understand that occlusion means a light that's been blocked by a surface, and when that happens you get these shadows, and depending on which part the light hits, it will give off a different intensity to the shadow. So read through ambient occlusion. Here's an explanation of how it works, and please do understand what ambient occlusion is, and the kind of renders you can get from it, how it can be used in your rendering as well. And the other part is this subsurface scattering, and some of you might experience this when you're playing around with the shaders in Maya, with the Arnold shaders in Maya. Well, here's an explanation of what subsurface scattering is, the kind of effect it's able to produce in your renders, and how you would want it in subjects like the human skin, leaves, fruits, candles, and whatnot. Here's an explanation of how it works, just to give you an idea of how things might look like without subsurface scattering and with subsurface scattering. Here's some more examples of what subsurface scattering looks like, and basically it's translucency, the way light kind of passes through a surface and scatters within it and gets reflected back. Well, with most of these terms, they're pretty much they could be a mouthful, but you really need to understand the concept behind it. Yeah, subsurface scattering, what it is and what kind of effects it can produce in your rendering. Yeah, and I would say that's pretty much it for chapter 7. Finally, let's go on to chapter 8. Now what you really need to focus on in chapter 8 is just this one page. It's safe to say that something like this, like the following tips are used to improve your composition, and a lot of this can be demonstrated in a work, and it's hard to kind of articulate what they are, but there's explanations here to kind of show you what they mean, each one of them. But safe to say, if you kind of memorize all this, you should be doing fine. But it's good if you kind of really understand what they are, because it's not about just memorizing, it's also understanding what they are and using it in your work. So by all means, please do read through this and understand it. I mean, it's much easier to kind of memorize all of this if you understand what each one of them means, right? So that's what I have for the revision part of this subject. I wish you all the best, and please do pay close attention to all of the chapters that I was talking about. Really understand it. I hope these slides will help you. But what you could do is as well, there's two books that are vital in our subject here. I'll just point you straight to where it is. If you open up the course outline, you'll find under textbook here. If you want, you can go and find these two books in particular. Most of the syllables from this subject was taken off these two books: Digital Modeling by William Vaughan, as well as Digital Lighting and Rendering by Jeremy Byrne. They're really good resources if you really want to understand all of the slides here. But yeah, I mean, it's for your own good. It's up to you if you want to read it or not. So please go through all those chapters. Again, good luck and happy studying. I wish you all the best. As well, I just want to say some last words. I hope that you guys do say hi if you see each other in the hallways, and I wish the best of luck in your modeling career in the future. Alright, that's all from me. Thank you very much, and it was nice to have you guys in the class. Bye.